Okay, so today we would like to introduce the new features of Amira in deep learning and how to use that. Microphone 有，这里的有开，所以它应该会有什么声音吗？
比较大声一点。
哦，这个 Hello? Oh, yeah. Okay, so it's working now. Yep. Before we start to demo the Amira, we will introduce some knowledge about the deep learning. Okay, so do you know what is it? Yes, of course, I guess. So have you ever tried to use the chat GPT? Yes, good, very good. So I trying to use the chat GPT to ask the software how to read a TIFF file in Python. And it gave me a very good answer. So it's quite good. And I think it's smarter than me in most of technology. Yeah, but sometimes it gets failed and you could not understand what had happened. So today we will introduce how to training a model that could fit your image analysis. Okay, so the next example is a Google translation. So you probably used it before, right? And the translation was improved a lot because of the attention layer. So if you look at the model itself, it's something like this one. It's complicated, right? And it's very difficult to understand if you do not have able to build a model by yourself. But actually, they have two parts. The one is the encoder, and the other one is the decoder. So it's like image processing that we were talking about later. Okay, so you probably also hearing about a GAN model. A GAN model means that you having a discriminator and have a generator. And the most popular apps to do the model training and the prediction is the pixel to pixel GAN model. Okay, so if you are interested, you could try to download in the GitHub and try to analyze your image by yourself. But how do you think a model, when you use a deep learning model, how do you think a deep learning model looking like? Okay, my experience that it's like a gray box. Yeah, but actually it was lot of function inside. Okay, you could thinking about that. A neuron was a function itself, but they have thousands or millions function inside the deep learning model. And what you could get from the model is that you give an input data and you get the results. Okay, so no matter the model it is look like something like this one. You're providing some input and you get the results. So today we will introduce how do you training your data set in Amira and how do you use the training model to predict your image for further analysis. Okay. So before that, we were having some basic knowledge to share to you. The first one is what is deep learning. Okay, we saw and we're hearing lots of about deep learning, but do you know what it is? Probably yes, probably not. So we simply explain what it is and how it works. It will help us to use the model to predict your image data. Okay, so wait. Sorry. Wait a moment. Okay. I think the screen having a oh yeah, it disappeared. This one.按一次啊。This one. Okay. And I hide everything. Okay, it's much more better. Yep. So you probably hearing about artificial intelligence, machine learning, deep learning lots of time, right? But do you know the relationship between each other? No. Okay. So actually, deep learning is one kind of machine learning. Okay. And all of this technology is inside of artificial intelligence. So if you use computer to solve your problem, it is one kind of artificial intelligence. So no matter what it is, okay? So you could use the computer to identify the sound is from a dog or is from a cat, okay? If it finishes this job, it is an artificial application. But what we use today is um, deep learning in image processing. So it could apply in different kind of application field, but we're talking about today is about how to use deep learning and machine learning in image processing. Okay, so what the difference between machine learning and deep learning? I use the two figures to explain very simply. If you are using a machine learning technology, you need to feature the extraction before using the machine learning. Okay, I will demonstrate Amira machine learning technology, okay, later in the presentation slides. And if you are using a deep learning model, you just need to provide an input and output, and the model will train it by yourself. Okay, so you didn't need to extract the features of your image data. You just provide the inputs and the outputs. The model will trying to learning the relationship between all of the image information. Okay, so why the deep learning was popular? Because it was easy. Okay, you don't need to get the feature, extract feature, or do a lot of preparation for your data set. You just provide the input and the output. Okay, so this was a very simple case to explain how the deep learning model was work. This was 28 by 28 image. Okay, for this case, what we want to identify is a number. So we are very easy, right? We say it is 3, but for computer, how to do that? Actually, it was vectorize the 28 by 28 image to lots of neurons. So you totally have 784 neurons in the fully connected neural networks models, and they have some hidden layers here. So after this connection, some neuron was fired, some neuron does not fire with the different connection and weighting factor inside the model. They will finally get the final results. For this example, we want to have a number 7. Okay, the next example, we want to have a number 2. So you could see that different number have different firing neurons. Using this kind of ideas, if we training a weighting factor for each of the neuron, we could somehow to identify an image is pixel 1 to 9 to number 1 to number 9. Okay. So if you want to know more about what is deep learning and some basic idea, you could browse the 3Brew1Brown website to check the more details. So we will not discussion this more later, more in this workshop. Okay, so the next part is that we were talking about the convolutional neural networks. So before the convolutional neural networks, you see the above the presentation that we use the fully connected neural networks. It means that pixel of the image was all the neurons of the input data, but in the real case, the image was huge. So it is not possible to vectorize all of the pixel to be the neuron to training the data. It would take so many times, and it would have not enough hardware compute performance to do that. So for image processing, we will propose you to use the convolutional neural networks. How it works? This was the example. This picture of bird, right? So how do you identify it is a bird instead of it is a cat? I think because you saw they have egg, very thin egg, okay, and they have some eyes. So we could see that we have red rectangle areas. We could identify the picture. It is something like we want to identified, right? So using this kind of idea, the convolutional neural networks actually was convolute some pixels of your image. So for this example, there was 3 by 3 filters. So after this convolution, they will get one value. So image was used lots of convolutional layer, and then finally they will extract the feature inside the neurons. Okay, so you could define by yourself what the filter look like and how many activation map you wanted in Amira, of course, and you could using these feature maps to training and then to prediction your image data set. So this was the most popular neural frameworks to do the image segmentation. Okay, so here I will explain later. So the point is that what the artificial intelligence in Amira Visual software we have provided. Okay, so the first one is the machine learning textual clarification in the segmentation workflow. With the machine learning textual clarification tools, you could simplify it to brush you could see that the red, blue, and the yellow area. And with some brush, something like this one, they will extend to somehow to figure out if there was similar patterns and complete the segmentation. So this was the real process to use these tools. So at the beginning, at the beginning you just need to draw some areas for different materials. So in the material list, you could setting it was I, A, or material 5. And you could then to predict if it was identified all of the slides with the same materials in the material list. So you could interactively to adjust the parameters and draw the areas to get a much better result you want to. Okay, so this was we call the machine learning. You need to extract the features you want to identify. Okay, so it is a little bit different with deep learning. We will explain later. Okay, so another kind of artificial intelligence is about deep learning. Okay, in deep learning, Amira providing the training interface and also the prediction module. So if you training a model by yourself, you can then using the training weighting factor to predict the similar data set. Okay, and I will also demonstrate the whole process that we used if we have in a well-training model and also how to training a model in Amira Visual software. Okay, so inside Amira, what we provided is a multi-phase deep learning modules. So you could specify how many classes you want to specify and how many neural networks you want to, what the depth of the UNet model and how many activation layers, something like this one, and you could adjust the learning rate, and I will explain this later. So with this well-training data, you could later to predict the similar image and get the result you wanted. So it was very different compared with the traditional image processing, because if you are process the image data using the traditional image segmentation, you probably get something like the left-hand side image results. All of the image with the similar intensity will be segmented to each other. But if we have training a model, it will to separate it was a membrane or not. Okay. Also, we could use the deep learning model to do the image noise reduction, something like this one. And in the last version, 2023.1, we having a deep learning noise to void approach deep learning package that you could training it didn't need to provide any ground truth to training the model. You just input your image data. You will training by yourself using the clarification group, and then they could remove the noise from your image data. So in some cases, it works very better. Something like this one. It will keep the membranes very high and with no noise inside, and keep very clear in the void areas. Okay, so you could try to use in the last version of noise to void. I will also demonstrate this part later. And if you are use deep learning training, the first things you need to do is to do the preparation. Okay, so what does it mean to do the data preparation? The data preparation actually is the data segmentation. Okay, because we need to have in a ground truth. So you need to use Amira segmentation workroom, or you could have in a workflow to extract the membrane, the materials you wanted to segment it. So the first step is like this. We will extract a partial of your image data set, and then we will do the segmentation for different region and areas. Something like this one. So blah, 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 blah. This will finish all of the segmentation. So the first step is not always use the manual segmentation. You could also use the segmentation workflow to extract the feature you wanted. It was the results you want to the model to learning. Okay, so the next part was training. Okay, we having already the ground truth, right? It was the segmentation data. So we use the deep learning training. In Amira, last version is calling the DL segmentation 2D or DL segmentation 3D. And this was different because of the convolutional layers inside the model is used 2D or 3D. Okay, so I will also demonstrate this parts later. Okay, so during the training, it was easy. You could use almost all of the default parameters. Okay, just provide two data set and having the output model path and adjust the number of epoch and check the loss function, what you want to use. And finally, just click the apply. With that, it sometimes take a little bit times, but it will like this one. You will having a loss function results, and you could see that if it was close your target result. Okay, yeah. After that, with this model, what we could use is use the training files to predict the data. So finish this training, you just calling the deep prediction modules and load the weighting files from the deep learning package. Okay, so after that, you could see that this was the result. Okay, so I switched to the software that what it works. So wait a moment. I load the data set. Okay. So this was the case that we are. Okay. This was the case that that's the slide shows that we're trying to segment the two parts of the image data set. So yep, you could see that we having a deep learning prediction modules. And what you need to do is to load the training data set with the full training. You could get the left-hand side was the ground truth and right-hand side was the prediction results. So it's very close to the ground truth. So it's the good, right? It's very easy and very good tools to do this kind of segmentation. So if it is, but if you want to develop a specific algorithm to separate this kind of object, wow, it's really very tough job. So okay, yeah. So with this prediction it actually doing was the semantic segmentation. So what does it mean? What we see was that it will separate the grays, the sheep, the rope, if we have a picture of something like this one. So in Amira, we could also doing the instance segmentation. If you want to do the instance segmentation, it means that we want to segment the different sheep in this picture. Okay, so if you see some papers that we could do this semantic segmentation, it means that you could identify different materials in your image. But if you want to do the similar image and separate each object, we're calling it the instance segmentation. So if you want to do the instance segmentation, what you need to do is further to having a border and the center plots. I will also demonstrate these plots later. And this was some case that we already did before. So for this, it was a CBCT image. So we want to extract all of the teeth. Okay, so what we need to do is the first things, again, we need to segment all of the teeth. And later, we just finding a model and training the data set to predict the results. So it already tests the CBCT data too. And another one is the confocal microscopy. For this case, it was very easy to having a nuclear in 2D slice, but somehow it's very difficult in 3D because you see the X, Y, Y, Z slice. All of the nuclei was close to each other, so it's quite difficult to do the segmentation using the traditional image processing or workflow, but it's quite easy to have in the model to do the prediction. I will also demonstrate this part. Okay, and this was another case from the clinical image. It's an MRI of foot. So again, we trying to separate the bone. Okay, what we could do is to segment all of the bone and then to training a model to trying to prediction. So this called the instance segmentation because all of the bone was similar materials and we want to separate it for this part. So we have already demonstrated two kinds of segmentation, right? The first part is semantic segmentation. So if you have in the image and it belonged to different materials and it could be identified by age, by intensity, something like this one, you could using deep learning and ground truth together to do the training. But if you want to do the instance segmentation like this, you will later I will introduce how to do that in Amira software. Okay, so how could we do the instance segmentation? So I will trying to demonstrate from the segmentation and everything in Amira. So first I load the software. Just wait a moment. Okay. Share the screen. Okay. Yep. So we load the data here. So this was the input data. We have 3 lobes. So for this case, if we want to training a model to predict the 3 lobes, we call it instance segmentation. So how do we do this kind of deep learning in Amira? The first step is that we will use the image segmentation tools. So right click and start the segmentation over. Just wait. I need to hide the screen. Wait a moment. Wait. Okay. Oh yeah. Okay, so for this, we know that there are 3 lobes, right? First, 1 and 2. So we could use the brush tools here. Define it was materials 1, and this was materials 2. This was material 3. And for any others, it was exteriors, okay? So we add the material 5. And later we could use the watershed segmentation. With that, we have finished the segmentation. Okay, so this was the ground truth. Okay, And if we want to do the segmentation, if we want to do the semantic segmentation, it is quite easy because you just need to identify it if it is a foreground or background. For this kind of case, you could use the segmentation thresholding and to convert image to binary. Okay, so this will be as the ground truth. Okay, so if you want to do the semantic segmentation, all you need to do is deep learning. Sorry, here it is. Deep training to deep and connect the ground truth here target to this one and specify the neural networks and output to the model and click apply. Everything is done. Okay, so it's quite easy if you want to do this kind of segmentation. But for this case, what we want to do is to do the semantic instant segmentation, right? So for this case, we will convert these three logs to border and the center point. So we could use this, I think it's, yeah, compute label layer, distant layers, and we could specify the two layers and the thickness, something like this one. So with this kind of computation, we will get the results like this one. So now we have two parts. The first is the border, the other one is the center part. So again, it will be a problem of clarification. Okay, so if you want to the inside model to do a instant segmentation, the first step you need to do is convert your label data to border and inner to do clarification, to convert the instant segmentation to be a clarification inside and outside clarification case. Okay, so also for this kind of computation, because the algorithm we use is 3D in the label distant layers. And what it will happen? It will happen means that you could see that in YZ. So for this case, you see that in any direction, it having a similar thickness of the border, but it is not what we want. It is because if we use 2D deep learning, what we wanted is that in XY plane, all of the border have a border and center. But in this case, you could see that in the very top areas. Let me check. Okay, so here, for this, it dismisses the center part. It only have a border. So for this kind of case, we will convert it to 2D planes. And you will see that it will keep that in all of the 2D direction having a border and center. So again, if you want to training a model, you need to specify you want to use a 2D model or 3D model. If you use a 2D models, because your input image data was 2D, so you need to make sure that your ground truth having all of the information, have very similar information on it. Okay, so after that, we could use the deep training segmentation 2D. Yeah, so again, click here and specify some parameters and give output path. Okay, sorry. Yeah, and just switch the loss function. What do you want to use? If it was multi-class, you could using the large code cross entropy. Yeah, will be get good results. And you could also toggle on the geometry transform. With the geometry transform, the input image will be flip and have some rotation or zoom in, and also have some image here. They will get the data augmentation and improve the training results for further prediction. Okay, so we could also toggle on the software. Okay, so everything was done. Just click apply. So sometimes it takes a little bit long time, but it depends on how the epoch and how the image data you was providing in Amira. Okay, so for this case, we only have in a 25 epoch to do the training. Yeah. So you will not so many long ones. Okay. Yeah, it's quite close to finish. After we could switch to another one before you finish. So why we need to do this kind of converting from a different separate label to be a border and the center point? It is because the training model we want to use is it could predict a new data set. If you did not do this kind of processing, it usually having an overfitting problem. It means that it could only predict the training data as you train. I mean that it could not predict in the new data set. But the target is that we want to use this model for further analysis. But if it is all the same, it was useless, right? So doing this kind of pre-processing or to make sure that your model was generalized enough to predict another new one. For example, what we want to predict is here we have in another lobes data set. Tutorials lobes 2. Okay, so this was totally different image data set with different orientation and slicing. Okay, so if you did not doing this kind of preparation to convert your label object to be a border and center, your model will not to do this kind of prediction. Okay, but with this training with border and the center, we could plan to use the deep learning prediction here. Okay, and to load the model that we trained. So just wait. Okay. Here. Okay. Yeah. So here we just apply because we only training some few steps, so the prediction result probably not very good. But if you having enough data set with a lot of training, the result will be much more better. Okay, so you could see that with few step training, it's could segment the border and also the center. And if we use the same models for the new data set that we never training again, so you could check if it works. If it works, it means that your approaching was good. If the data was failed, you will need to understand why it gave a fail result. For this example, this part was okay, right? This is very close, but this was failed. So you could check what has happened. It is because they have very similar border like this. So what we need to do is input a new data set in these areas and to training your model again. It will improve the results. Okay, so if you want to use semantic segmentation, what you need to do is just to do the segmentation and then using the deep training package modules inside Amira. Yep, here. And if you want to do the instance segmentation, what you need to do is to use the layer distance, compute the labels to be a border and center, and later you could use the watershed segmentation to complete the labeling segmentation. Okay, Yeah. So I have another case is from microscopy here. This was the model I already trained to predict the nuclear image data set, like this one here. So this case in XY it was quite easy, right? It is very easy to identify it was a nuclear. But if you switched to XZ, well, it will be merged together for every of the nuclear. So it was very difficult to do the segmentation. But if we having training a model, what we could get is having this model we use is to having a density map and density probability. So it will be the center will be the great part and the boundary will be low value. So the input image is this one, okay, and the output results was like this one, okay, something like this one. So with this kind of prediction, later we could use a very simple in Amira to use the interactive trace holding first and to identify the center of the nuclear. So we could have a lower value, and later we could use the labeling. With the labeling, we were having all of the markers of the nuclear, something like this one. So you could see that we got lots of nuclear center in different labeling. And later we could, using the thresholding again.
Can you also tell us, like, this was the confocal image.
Yeah.
So it was taken in the Z section.
Yes.
Okay.
Yes.
Do you also have the raw image?
Raw imaging?
This one.
This one here. Okay, just one. Yep, this was the low image. Here.
So, what determines the thickness? Just the like image we have, the information is going to process of that.
Mm-hmm.
Thickness of the nuclei.
Thickness. Then I didn't measure it, but uh,
How does this?
What I want to share with you is that during the training, we didn't need to provide the thickness, everything.
Much information, so you can.
Yeah. We just training it. You just provide the input and output. The model will learning by yourself. So you did not need to provide what the size of your nucleus, what the diameter, what the.
So if I have like if I train the model and like if I have the image, it has 7Z section, right? So I can apply this model to the A
Yes.
or 9. So I can apply it to the different slices.
Yes. But because we use the convolutional neural networks, it means that we having a respect field. So we need to check if your voxel size or image resolution is similar with this or not. If it is, it's not a problem to predict your image data set. Yeah. Okay. So with this, we having a marker, right? So the next we want to having a background mask. So the background mask means that we need to check if it was a nuclear or not. So you could as low possible as this. So we could get lots of something like this one, but always the same intensity, right? So we could finally use the watershed segmentation. I'm sorry. Watershed segmentation inside the mask. Okay, and connected the markers to the labeling, the binary mask to here. So it will labeling using the markers information and to extend to the whole binary labels. So I explain it again. So the input was something like this one. the labeling index will be used this one, and the label boundary we're using this one. So what the actual result is like this. Okay, so we could finally get an instance segmentation using Amira if you have already a model. And also in the new version of Amira, it is complicated for most of users, I believe, because there are lots of workflow steps, right? So in the new version, we have in the image recipe designer. It means that I demonstrate the results for you first and introduce how to do that. So I have already a modules here. I naming it as prediction labeling recipe. So I could use the module and apply, and I could get the results without any further parameter adjustment. Okay, so how could I create this kind of recipe? You could use the image recipe designer. So it's quite straightforward as the workflow you did in the project files. So the first step is loading our data set here. And just I showed before, we're using the thresholding. Threshold here. Okay. So you just adjust the parameters. Okay, so it was as low as possible because we don't want the nuclear was connect to each other. So we need to get separated. So the value was not too higher. Okay, because we only need the center parts. Okay, after that we're doing the labeling. So you was finding that it's very similar that we are doing before in the recipe workroom. Okay, so the next step, we will change the reference step. So we change it to the input data again, and we do the thresholding here. Okay, in this case, we will create a binary mask for the output results. Okay, so final step is that we change the input reference step again, and we use this, and we connect to the watershed inside mask. So here we choosing the labeling, marker, and background. Okay, so we have finished the recipe design. Okay, so we could save it by yourself, Seneca, in the case. Yep. And here you could define how many data set you want to output. Okay, if you want to extract all of the image information in your room, you could choose the data you want to export. But in this case, we only want the final result. Okay, so we only keep this one. So I come back to the project and I right click. You could in the image recipe, you could find in the recipe that we have designed in the image recipe design. Okay, so you just apply, you will get the final result. So it will quite efficient if you want to do the similar data set and similar processing. You could try to image recipe designer. Image recipe designer is not only designed for deep learning data set, it also you could use for different kind of a workflow design. Yeah, it could combine lots of module and program together to get a final result. It could also separate lots of processing steps to different kind of recipe, and then you could combine it together to do this. And also in the new image recipe designer, they were having a sorry, I switch. They were having some new feature like this one. It will keep some ports that you could adjust for further analysis. For this case, I didn't specify here, but I specified in my previous design, right? If you want to do this kind of settings, what you need to do is here we having a pinpoint here, just specify and naming the port what you want your user to use. So for this case, it was marker labeling. Sorry, marker threshold. So you could specify it as a marker threshold. And another one, this you could specify a background. So it's a binary threshold, something like this. Okay. With this, we save it recipe and we come back. So attach this again. You could see that we have in the 2 parameters inside the recipe. So you could use these parameters and you don't need to go back to the image recipe designer to redesign your workflow again. So it was quite efficient if you have lots of data to do this kind of image processing.
So save this one.
Pardon?
The one that simply made. So can I also save this one?
This one? You mean that
can I also save this?
Yes, it's only the workflow. So if you want to save all the project, here is you want to need to do. So you could save projects. So it will save all the project, but the recipe is only the workflow, the module you use to do the image processing. So it's a little bit different. And also we have in new features, export as Aviso to Go. It provides that you could install the Aviso Amira in all of your computer with free. Okay. So if you having a computer in your labs and you want to interactive to browse your data set, you could now to download the Aviso to Go first. And then here you could export your project as Aviso to Go. Later you could use in your lab computer to browse and interactive to check your data set. But the only difference is that they could not use the computer module or change the data set you want to visualize. Okay? Because they save all of the information together in the software. So, any question for this part? If it is no question, we will move to another. Is also the artificial intelligence in Amira that we will share with you. It is also the new feature in Amira. So I will, sorry. How could I cross? Just wait a moment. Okay, so I started, sorry. I start the software again. Let me share here. Okay. So another artificial intelligence technology was in the new segmentation model. Let me load the image data set first. Wait a minute. Here. Okay. So yeah. So this was from the TEM image, I guess. Here. So for this case, yeah. So in the past, if you want to segment this diffusion, it's quite difficult, right? Because the intensity was not very clear to identify each other. But in the new segmentation world, it will become very easy. So let me load the image data set first. And because the YZ and XZ is not clear for us to identify, so we just, as before, we switch to the XY plane only. Okay, so what we need to do and what we could do for this case to do the segmentation is that we could menu segment for some Libson first, and the model will learn it by itself. So for this case, I brush the boundary. Yeah. Okay. So this was the first case. Okay, this was the second case. Okay. Sorry. Okay. So I could draw some targets that the model to learn. Okay, so I only draw 3 Libson, and with that we could create a page. This page will make the model to learn it. Where is the target image you wanted? for this case, because it was a little bit, I mean that because with the page size, we have many different page size. But if you choose a very big one, you need to make sure that all of the areas you have finished the ground truth segmentation. So in this case, we choose the small one. With the small one, you want, okay, we could specify this, yeah. With that only, yeah. And also this was the background. So we just tell the software, this was the background, this was also the background. Okay, so with that, we could use the artificial intelligence segmentation, just create selections. With these modules, it will use your segmented results and trying to segment the whole volume data set. And if the data was not corrected, you could also adjust and approach to increase the data set. So you can see that we have already get more labels here. So it is not good enough, right? So we could go back. We could go back to the segmentation war room again. Yeah, brush the tool. So as more as you segment it, the training data will be more close to your expansion. So for this case, I increase 3 more lots, something like this one. Okay. So I add this one. Okay. And then add some, let's say. So for this, if we have touched the border, okay, let's try the second one. Okay. After finish that, you'll be using the tools again. So with more interactive segmentation, the final selection will be more close to what you wanted. And you will be save lots of time to do a very complicated segmentation task. So you could try these features in the new segmentation order. So you could see that it was much more closer than what we wanted. Okay. So if you do more manual segmentation, the results were more close what you needed. Okay, so this was the another case that we could use the deep learning. I mean, use the use the artificial intelligence tools in Amira to help you to do the image segmentation. Another case was I have already presented in the slides that we have new features, namely the noise. Here, the noise, we have a noise to void 2D. This actually used unsupervised segmentation. So you could see that there was no target pose. So it just training the image data set, you just apply. Sorry, because I didn't specify the output directory. So just again here. So apply. And they were trying to learn the relationship between inside your image data set and remove the noise and then to give you a clear image data set. So the use case is here, but for the liposome case, I have tried it, it's not good enough. But for others, you could try it by yourself. You didn't need to providing any target image. Okay, so what you need to do is attach the deep learning noise to void 2D and you will training and to do the clarification and trying to grouping the background noise and your image data set. Okay, so after this training, we will get a waiting data set, and later you could use here deep learning prediction and browse to the here model, okay, and later apply. But for this case, I didn't think it's good enough. But for other case, you could try it by yourself. Because unsupervised training is not always good enough because they separate your image from foreground and background, but sometimes it will confuse to segment if it was not clear to grouping the intensity information. Okay, so this was the raw image data set, and this was the field results here. Okay, so it's not very good, but it's a tool that you could try to remove your noise background image. Okay, so this was another case, and another one was what we have developed for some of our customers. You probably could be tried if you want it. Okay, so this was we discussed with our customer, and we designed a deep learning model for their purpose to extract the trachea. Actually, I probably could demonstrate the knowledge inside this plot and share some experience. This case was to extract the trachea, but actually all of the thin and long object could be extracted. Okay, so this was the trachea. Okay, so this was the case. So in okay, lots of slides, but I think we could only share some key points. Okay, so for deep learning, you already see that what we do or we use is we providing the inputs, right? We input an image or a text or a words or something else and put inside the model. And there could be two kind of a prediction. One kind is to do the regression analysis. Another was to do the clarification. And recently, most of the user was to do the generative learning. And this was what we are looking for. And we hope we a model could do this kind of analysis. So if you want to develop a model by yourself, there was 3 steps, okay? If you don't need to develop a model by yourself, you could use the DL segmentation 2D or DL segmentation 3D inside Amira. But if you want to develop a model by yourself, like we do, you will keep in mind that you have 3 steps to finish. The first one is to find a model that fit your problem, and the second one is to check what those functions you wanted, and finally was to use the optimization step what you could be used. So there are lots of tools already. So we did not discuss this, but what I share is that the model we developed for interactive segmentation was because the customer asked us to extract the nerve from MRI image, and it was quite challenging because it's something like this one. In these areas, we want to extract the neuron. Okay, so it's very tough case, and what we need to do is to develop a growing model. So inside our model, actually, we have a 2 input. So it's something different from the Amira default training model, because the training model in Amira only provide 1 input. So I could not have 2 input, right? So I need to write the model by myself. So inside my model, I could having a 2 input. So these 2 input was together to having a new prediction and later. So you could see the animation like this one. So we having a seed position, and with this seed position, we predict the small region of interest. And later we will extend the boundary and extend again. So we're looking all of the process to having the result what we wanted. So using this case was to let you know that in Amira, it is very easy to combine different kind of technology together or develop your own apps by yourself. So for this case, we use the ideas of the iterative segmentation in deep learning. So as I said, that we have a first seed, and then we will extract the region of interest. So actually, the prediction was very small one region, something like this one. So with the mask and the input image, we will predict the grade one, like this one. So we're labeling this as a blue, and with some touch phase, we were having a new extraction again. So looping the process, we could finally extract a very complicated cases. So this example was just to share with you is because in training case, it is not possible that we could gather lots of data set by ourselves. For the nuclear, we also only segment parts of the image data only. We did not it is not possible to get all of the image data in the world and trying to do all the segmentation and the training. So what you could do is trying to specify your problem, and that it was simple enough for your model to learning. So for this case, in our model, it's only learn something like this one, because the picture will be very complicated for a neuron, for a trachea. But for our model, it's only learn this kind of maps. Okay, so you know that it's a cylinder-like structure, so we could segment this one. Okay, so it was easy enough. So for this case, what I want to share with all of you is that if you're having a very challenging case and you want to use the deep learning training to complete your segmentation, the first task you need to do is trying to simplify your image data set. And it is only you that could explain, that could understand the structure it is. So it is possible that only you could separate the data set as simple as possible for a model to run. Okay, so I use these two input channel and use the UNet model to do the prediction. And you could also develop a model by yourself inside Amira for further analysis. But if you only have one input channel, you don't need to develop. You could use the inside model in Amira to do the training and prediction. And yeah, it's some application that we have did using this technology. We could segment the mandibular canal. It is quite challenged before because the intensity was not good to identify. And also we have used this technology to low dosage aorta segmentation. So this one, okay, yep. And trachea, I think you already see it. And also it was a vessel in the kidney. So if you have a very thinner and longer part, and previously, if you want to train this kind of model, it will be very complicated, right? But if I just extract a very small, like a final element, okay? So it will simplify your problem, and it will be easy to training a model to do the prediction and without lots of huge data. Otherwise, for this kind of segmentation, you probably need 10 or more subjects with different spread of the basal structure to train. But with this model, it will be very easy, because if you only look a very small part of the region, it was look like a cylinder only. Okay, so this was the case. What I will share, we have also used the in the basal, and this kind of prediction was quite efficient. Yeah, it only take 6 to 10 seconds to finish. Okay. Yeah. No problem. Good. Yeah. Okay. So there is only there's also some tips for deep learning training if you are trying to train your data set. Some tips I was for you. The first one is that this was I don't I think all of you understand. But if you want to train the model, which part of words is better at the beginning? In my experience, you providing the bottom call like this is easy to train the model before you give this kind of lot of words with lots of annotation. I mean that when you're training a model, the first step is you need to help your model to remove all of the unnecessary information before training it. Because you provide lots of information, it's quite difficult to rule out a data set, or I mean that it is very difficult for a model to identify this difference. Okay, so the first step, I think the preparation is very important for your data prediction and learning. Okay, so you could try to simplify your image data set. And another problem we usually to see is that the overfitting. Okay, overfitting is something like this one. It was the if you want to do the data classification, so they having a green circle and a purple star. Okay, so the perfect line is in the middle. Okay, but if it is overfitting, it is something like this one. So overfitting will getting a problem that it could not predict any new data set. So we were trying to training a model that will be generalized enough to predict the different kind of data set. It will be a good model to do that. So data augmentation and data regularization is also very key to training a data set. And also the learning rate. If your learning rate is too high, it will probably not a good case. Okay, so there are lots of different training curves you could reference to check if your learning rate is too quickly or it is good enough. Okay, so this was two cases that I training the data set before. So for this case, the blue one was the training data set, and the red one was the validation case. So if your training data was having this the top area curve, you could continue to training your data set because it could be improved. But if you find your training curve is something like this one, your your validation data set could not be improved. It will be having overfitting already. So stop the training and trying to provide different data set when you're training your data set. Okay, so this was two case, and this was animal. Yeah. Okay, so this case was that if you are doing a classification and your model never see the data set before, it will be get a fault. I mean that, do you know this was right or bad? No, it's II. So it was not the cases. So if your training classification was not included in your model, you could not expect it will get the result you wanted. Okay, so keep in mind, it's very important. Another case that I having lots of I got lots of problem before is this picture. This was a seal. I think it's a seal. Not sea lion. I don't know, but you can anyway. We all know that these two pictures the same, right? But if you using the convolutional neural networks, it will identify as different. It is because the respect field was different. Because the respect field in the left-hand side was very small, right? But in this area, it was all dark. So it probably identified it as a background, not a real case. So you need to keep in mind if you have a different voxel size image data set and you want to train it, you need to make sure that they did not having they need to have a closed voxel size. I mean that you cannot have different voxel size. With different, it will be very hard to train in your data set. And also, this was some suggestion if you start trying to use the deep learning for your research. So I think the first step is to use a source file you are familiar with, because in most of the case, you didn't know what happens. I mean that you training a model, but it failed. So it is very difficult to identify if it is failed or it works. So the base one is that you are having use a source file you are familiar with. It will help you to identify the problem it is. And also they already have lots of neural networks model, so you don't need to design by yourself. You just download a previous achievements and do some modification. I think it's good enough, better than you rewrite it by yourself. And also, you need to repeat to reading the new technology, because deep learning was improve day to day. So it's quite having a new technology today after before. So reading new technology is also very important. And also, not all the problem need to use the artificial intelligence. If your case was easy enough, just trying to use a workflow inside Amira, you could design a recipe workflow to do that. So because training data, you need to provide enough information, it will get the results. If your data is too few, it's really very difficult to training. So that's all. I think that's应该没有人有问题，不过没有关系。如果大家有任何问题的话，因为我们有一个群组嘛，所以可以在群组上问，包括深度学习啊，因为我们一直在学习这些深度学习模型的训练，所以如果有资料要我们帮忙训练也是可以。我们有帮硬科中心他们有一些复杂的案例，那我们就会帮他们训练模型，让他们去做测试，这样也可以节省很多时间。对，所以只要手上，虽然今天可能参加的不多，但是只要看到影片的，有需要的话都可以再跟我们讲，对，我们再帮你们做。嗨，好，那今天先这样，谢谢大家。那我先把录影关掉。